Hello all, welcome to the fifth episode of the Introduction to Functions. Here in this discussion we are going to talk about how do we solve the system of equations. We saw earlier that we can essentially plot any system of equations and we can find the point of intersection on the xy graph, which is the solution of the equations, right? But it may not be super easy or convenient or fast to plot the equations every time on the graph, and hence we are going to use some standard mathematical methods or ways to solve the system of equations, right? We have essentially two methods, substitution method and elimination. Now, before we get into the details of each of these methods, I want to talk about a basic math rule. And that basic math rule says is that whatever number of variables you have which you are solving for, you will need to have that many number of equations. So for example, if you have two variables x and y, you will need two equations. If you have three variables, let's say x, y, and z, then you will need three equations and so on and so forth. For the purpose of our discussion, we will keep ourselves confined to two variables with two equations. So let's get into the substitution method now. Let's look at the substitution method, and let's say that we are trying to solve this system of equations using this method. In the substitution method, as the name suggests, we write any one of the variables in terms of the other variable and then substitute that value into the other equation and solve for it. Let's see what I mean by that. So if we look at equation 1, we can move 3 to the left side, right? So let's say we have 2x is equal to y plus 3, and we do minus 3 here and a minus 3 here, and we get 2x minus 3 is equal to y, right? So we have rewritten equation 1 in such a way that y is written in terms of x. We now substitute this value of y into the second equation so that the second equation completely becomes in x. So the second equation becomes minus 3 times 2x minus 3 plus 5x is equal to 9. We expand this, it gets minus 6x plus 9 plus 5x is equal to 9. And when we solve it, we essentially get x is equal to 0, right? So we got the value of x, which we can now plug back in either of these equations to find the value of y. Let's say we decide to put the value of x in equation 1, which will give us 2 times 0 is equal to y plus 3, or in other words, y is equal to minus 3. So basically 0 comma minus 3, x comma y is the solution to this system of equations. Essentially, as we saw earlier, 0 comma minus 3 is the point of intersection of these two straight lines. Let's look at the other method, elimination, now. If we take the example of the previous equations, right, it was very easy for us to move 3 to the left side, write y in terms of x, and then substitute the value of y in the second equation, right? But let's say instead of y, we have 5y. In this case, it may not be that easy or convenient for us to write y in terms of x or write x in terms of y. I mean, we can still do that, but that will be in terms of fractions, and then substituting that value into the other equation will make it all the more complex. So these are the types of situations wherein the substitution is not straightforward. We use this method, elimination, right? So it's very, very important to understand, for us to understand that in what situations we use elimination. Now there are different steps in this method. The very first step in this method is the alignment, the vertical alignment of the equations, right? So the x has to be below the x, the y has to be below the y, and the constant term has to be below the constant term. No matter, all of them could be on one side, or two terms are on the left side and one on the right side, doesn't matter, but they have to be vertically aligned. So let's see that how the vertical alignment of something like this looks like. Now also it's solely up to us in terms of what we want to move where. So let's do step 1, the vertical alignment. We see that the y and the x terms on equation 2 are on the left side, whereas that is not the case in equation 1. So one way of doing could be that we move the y term to the left side, so that for equation 1 also the x and y are on the left side. So when we do that, equation 1 becomes something like this. Minus 5y plus 2x is equal to 3. This is our equation 1, because we moved 5y to the left side. So we did negative 5y here and negative 5y here, and this is how it looks like. Equation 2 remains as is. So minus 3y plus 5x is equal to 9. At this point of time, we see that our equations are vertically aligned. The y terms are below each other, the x terms are below each other, and the constant terms are below each other. Now let's go to the step 2, wherein we decide which variable we want to eliminate and how do we do that. Now that we have got the two equations vertically aligned, let's go to step 2, wherein we will decide one of the variables to be eliminated. In this case, let's say that we want to eliminate x, right? The thing which you got to remember is that the variable which we want to eliminate, the coefficients of that variable have to be the negative of each other in each of the equations. Clearly that is not the case here, because the coefficient of x here is 2 and here it is 5. Clearly they are not the same. So we're going to do some operations to make them same. Let's say if we multiply equation 1 with negative 5, and if we multiply equation 2 with 2, let's see what happens. Equation 1 becomes 25y minus 5 times minus 5y is 25y minus 10x is equal to minus 15. This is our new equation 1. Equation 2 becomes minus 6y minus 3y times 2 is minus 6y plus 10x is equal to 18. So these are our new equations. This is our equation 1, this is our equation 2. Essentially they are the same as the original equation because we are doing the operations on both the sides. Remember, as long as we do the same operation on both the sides of the equation remains same. Once we have done this, we are going to add both the equations. We are going to do 1 plus 2. When we do 1 plus 2, we're going to add each of the respective terms. So 25y minus 6y is going to be 19y. Minus 10x plus 10x cancels out, becomes 0. This is what we wanted. We wanted to eliminate x, right? Is equal to minus 15 plus 18 is 3. So essentially, we got 19y plus 0 is 19y is equal to 3. And then we divide by 19 on both sides to get y is equal to 3 over 19. So you see how we transformed these equations and how we eliminated one of the variables and found out the value of the other variable. Now we can just plug in this value of y into any of the original equations and find the corresponding value of x. So this is how the elimination method works. As we saw, the first step is to align the equations vertically. The second step is to identify which is the variable which we want to eliminate. Sometimes we may need to do some operations like this to eliminate the variable, get the value or find the value of the other variable, and eventually find the value of the first variable as well. Hope you guys got a good understanding on each of these methods, substitution and elimination. Essentially, when do we use them and how do we use them. Hope you guys liked the video. If you did, please do like and subscribe.